Hello everyone, and welcome back to another StudyingWorks video. In this video, we are going to go over the concept of mass spectroscopy in chemistry. Now, a mass spectroscopy problem has two different steps. So first, you have to be able to interpret a graph that is given to you, usually having percent abundance or relative intensity. The next part of mass spectroscopy is being able to find average atomic mass, which if you had taken a chemistry course before AP Chemistry, you would likely know how to do. Without further ado, let's get into the video. Before going over the two steps involved in mass spectroscopy, we need to first understand how we are collecting the data that is given to us. And this data is found through a mass spectrometer. And this machine right here is the mass spectrometer. And there are four different steps that occur in the mass spectrometer. So first, we will have our sample go in right here, and it could be any element. And this element, let's say it is sodium. This sodium is going to go through this passageway, and it is usually going to become ionized to a 1+ ion. And that process is called ionization, and that is the first process. So that's process number 1 right here. And then process number 2 is the sodium ion being accelerated through this tube, in which is called acceleration, and that is our second process. Now, our third process is when it runs into this magnet, and based on the atomic mass, the charges may vary, causing different isotopes to go on different sections of this little tube here, and that is called deflection, which is process number 3. Finally, at the very bottom, we go to detection, which is where we are going to get all of our results. And that is how a mass spectrometer works. Now that we have an idea of that, let's get into actual problems with graphs. Let's take a look at this problem with the graph. So calculate the average atomic mass of chlorine based on the percent abundances given in the graph. So we are finding the average atomic mass of chlorine, and we are given the percent abundances. And now, what does this mean? So looking at this, we have chlorine's two isotopes with a mass of 35 and a mass of 37, and the one with the mass of 35 has a percent abundance of 76, and the one with the mass of 37 has a percent abundance of 24. Now this is where most people get tricked. Now when you're finding average atomic mass, you are not just adding 35 and 37 and dividing it by 2. You have to multiply the mass by its percent abundance and then add it to the other masses times their percent abundances. So for this one, we would have this formula right here. And now if we plug this into our calculator, we will get 35.48. And if we look at chlorine's actual atomic mass is 35.45, which is close enough to the number we got. So this is the atomic mass that we got based on the percent abundances given. Although we have solved this problem, there might sometimes be different questions, and so we have to also review those questions. For example, if you remember, chlorine is naturally a diatomic in nature, meaning sometimes it could ask for all of the possible diatomic chlorine isotopes. And so how would we find that? So based on the percent abundances we are given and the masses, we know how many possibilities there will be, or rather, we don't know yet, but we can figure it out very easily. So we know there are only two types of isotopes, one with a mass of 35 and one with a mass of 37. So to find the different diatomics, we just have to find all of the different combinations of these isotopes. One of the combinations could be 35 plus 35, which is equal to 70. One of them could be 35 plus 37, which is 72. And we could also have 37 plus 37, which is equal to 74. And now those are all of our possibilities. And now we can add that to our graph here. And usually a mass spectrometer will give you this in the results. And so now how can we predict their percent abundances? So we know that the isotope with 35 is the most common isotope for chlorine with just a monoatomic isotope. So when we have our diatomic isotope, this one is clearly going to be the most common, and it's going to be more common than the previous one. Now, for 72, this is a combination of 35 and 37, so pretty common and not so common, so we end up with somewhere in the middle. Now 74, it is a combination of the two least common, so it is going to be even less, something like this. And that is how you can find the percent abundances of the diatomics based on what you are given in the earlier graph. Now there's one final trick question that could get thrown at you on an AP test, and you have to make sure you're ready for it. On this one we have calculate the average atomic mass of chlorine based on the relative intensity. So this time we are not given percent abundance. Percent abundance, all of our numbers always add up to 100 because it's a percentage. But with relative intensity, how it works is our most common one always has a relative intensity of 100. And then our other one is found relative to whatever we have right here. In this case it's a given, but sometimes you might have to figure it out on your own. So make sure you read the problem and check whether it asks for relative intensity or percent abundance. So now in this case, all you have to do is, rather than making it out of 100, you have to make it out of however much we have, which is 132. So in this case we have again our mass of 35, and as you can see in this, we have 35 times 100 divided by 132, which is the total, plus 37 times 32 divided by 132. We have to make sure we're paying attention to these totals. And if we multiply that out, we will get 35.48, which is again close enough to our actual chlorine atomic mass, which is 35.45. And this would be our answer. So that is it for mass spectroscopy. Thank you for watching, and I hope you learned something useful from this video, and hopefully it'll help you on the AP test when that time comes. And I will see you in the next video.